For DAD, add register pair to H and L registers the 16-bit contents of the specified register pair or added to the contents of the HL register, and sum is saved in the HL register. After the execution of the instruction, the contents of the stack pointer register are not altered. Logical instructions end ANA. Logical end with accumulator. Opcode is ANA. Operand is R bar M. Bytes 1. M cycles 1 by 2. T states 4. T bar 70. The description, the contents of the accumulator are logically ended with the contents of the operand register or memory. The result is placed in the accumulator ANI. And immediate with accumulator. Opcode ANI. Operand 8-bit data. Bytes 2 bytes. M cycles 2. T states 70. Description, the contents of the accumulator are logically ended with the 8-bit data operand. Result is placed in the accumulator. Flags AC equal to 1, CY equal to 0. After execution, ORA logically OR with accumulator. Opcode ORA operand R bar M. Bytes 1. M cycles 1 by 2. T states 4. T bar 70. Descriptions, the contents of the accumulator are logically ORed with the contents of the operand register or memory. ORI logically or immediate. Opcode ORI operand 8-bit data bytes 2. M cycles 2. T states 70. Description, the contents of the accumulator are logically ORed with the 8-bit data in the operand. The result is placed in the accumulator. Flags AC equal to 0, CY equal to 0. After execution, XRA exclusive OR with accumulator. Opcode XRA operand R bar M. Bytes 1. M cycles 1 by 2. T states 4. T bar 70. Description, the contents of the operand register memory are exclusive OR with the contents of the accumulator. XRI exclusive OR immediate with accumulator. Opcode XRI operand 8-bit data bytes 2. M cycles 2. T states 70. Description, the 8-bit data operand are exclusive OR with the contents of the accumulator, and the result is placed in the accumulator. Flags Z, S, P are altered to reflect the results of the operation. CY and AC are reset. CMA complement accumulator. Opcode CMA operand none. Bytes 1. M cycles 1. T states 4T. The description, the contents of the accumulator are complemented. Flags, no flags are affected. CMP compare with accumulator. Opcode CMP operand R bar M. Bytes 1. M cycles 1 by 2. T states 4. T bar 70. Description, the contents of the operand register memory are compared with the contents of the accumulator. Both contents are preserved. In the comparison is shown by setting the flags as 0. If A less than R by M, carry flag is set and 0 flag is reset. If A equal to R by M, 0 flag is set and carry flag is reset. If A greater than R by M, carry and 0 flags are reset. The comparison of 2 bytes is performed by subtracting the contents of the operand from the contents of the accumulator. However, neither contents are modified. Flags S, P, A, C are also modified in addition to Z and CY to reflect the results of the operation. CPI compare immediate with the accumulator. Opcode CPI operand 8-bit bytes 2. M cycles 2. T states 70. Description, the second byte 8-bit data is compared with the contents of the accumulator. If A less than data, carry flag is set and 0 flag is reset. If A equal to data, 0 flag is set and carry flag is reset. If A greater than data, carry and 0 flags are reset. The comparison of 2 bytes is performed by subtracting the data byte from the contents of the accumulator. However, neither contents are modified. Flags S, P, A, C are also modified in addition to Z and CY to reflect the results in the operation. CMC complement carry. Opcode CMC operand and bytes 1. M cycles 1. T states 40. Description, the carry flag is complemented. Flags, the carry flag is modified. No other flags are affected. STC set carry. Opcode STC operand none. Bytes 1. M cycles 1. T states 40. Description, the carry flag is set. Flags, no other flags are affected. RLC rotate accumulator left. Opcode RLC operand none. Bytes 1. M cycles 1. T states 40. Description, each binary bit of the accumulator is rotated left by one position. Bit D7 is placed in the position of D0 as well as in the carry flag. Flags CY is modified according to bit D7. S, Z, P, AC are not affected. RAL rotate accumulator left through carry. opcode RAL, operand none, bytes 1, M cycles 1, T states 4T. Description: each binary bit of the accumulator is rotated left by one position to the carry flag. Bit D7 is placed in the bit in the carry flag, and the carry flag is placed in the least significant position D0. Flags CY is modified according to bit D7. S, Z, A, C, P are not affected. RRC, rotate accumulator right. Opcode RRC, operand none, bytes 1, M cycles 1, T states 1. Description: each binary bit of the accumulator is rotated right by one position. Bit D0 is placed in the position of D7 as well as in the carry flag. Flags CY is modified according to bit D0. S, Z, P, A, C are not affected. RAR, rotate accumulator right through carry. Opcode RAR, operand none, bytes 1, M cycles 1, T states 4T. Description: each binary bit of the accumulator is rotated right by one position through the carry flag. Bit D0 is placed in the carry flag, and the bit in the carry flag is placed in the most significant position D7. Flags CY is modified according to bit D0. S, Z, P, A, C are not affected. Branch control instructions: JMP unconditionally opcode JMP, operand 16-bit bytes 3, M cycles 3, T states 10T. Description: this instruction is equivalent to 1 byte unconditional jump instruction. The program sequence is transferred to the memory location specified by the 16-bit addresses. Conditional jump opcode carry equal to 1, JC 16-bit 3, 2 bar 3, 7 bar 10, carry equal to 0, JNC 0 equal to 1, JZ 0 equal to 0, JNZ, sign equal to 1, JM, sign equal to 0, JP, parity equal to 1, JPE, parity equal to 0, JP0. Description: jump execution of a program immediately at the given address if condition is true. The machine cycles and 10T states are consumed if condition is true, while 2 machine cycles and 70 states are consumed if condition is false. PCHL, load program counter with HL contents. PCHL, operand none, bytes 1, M cycles 1, T state 60. Description: the contents of registers of H and L are copied into the program counter. Flags: no flags are affected. CALL, unconditional subroutine call. Opcode call, operand 16-bit address, bytes 3, M cycles 5, T states 18T. Description: the program sequence is transferred to the address specified by the operand. Before the transfer, the address of the next instruction to call. The contents of the program counter is pushed on the stack. Flags: no flags are affected. Conditional call. Opcode carry equal to 1, CC equal to 0, CNC 0 equal to 1, CZ equal to 0, CNZ, sign equal to 1, CM equal to 0, CP, parity equal to 1, CPE, parity equal to 0, CPO 16-bit 3, 2 bar 5, T states 9 bar 18. Description: call immediately. The subroutine stored at given 16-bit address if condition is true. 5 machine cycles and 18T states are consumed if condition is true, while 2 machine cycles and 90 states are consumed if condition is false. RAT, return from subroutine unconditionally. RAT none 1, 3, 10T. The program sequence is transferred from the subroutine to the calling program. The instruction is equivalent to the pop program. Flags: no flag is affected. Conditional return, carry equal to 1, RC, carry equal to 0, RNC 0 equal to 1, RZ 0 equal to 0, RNZ, sign equal to 1, RM, sign equal to 0, RP, parity equal to 1, RPE, parity equal to 0, RPO. Return to main program if condition is true. 3 machine cycles and 20 states are consumed if condition is true, while 1 machine and 60 states are consumed if condition is false. XTHL, exchange of H and L with top of stack. Opcode XTHL, operand none, bytes 1, M cycles 5, 3 states 16T. Description: the contents of the L registers are exchanged with the stack location pointed out by the contents of the stack pointer register. The contents of the H register are exchanged with the next stack location SP plus 1. No flags are affected. Stack input output machine control instructions. NOP, no operation. Opcode NOP, operand none, bytes 1, M cycles 1, T states 4T. Description: no operation is performed. Comments: the instruction is used to fill in time delays or delete and insert instructions while troubleshooting. HLT, halt and enter wait state. HLT, operand and bytes none, M cycles 2 or more, T states 5T or more. Description: the microprocessor finishes executing the current instruction, halts any further instruction. NOP and HLT are both are same as no operation. However, when NOP is executed, the PC is increased by 1 time, whereas HLT PC remains the same. Push registers pair onto stack. push code, push operand RP bytes 1, M cycles 3, T states 12T. The contents of the register pair designated in the operand are copied into the stack in the following sequence. The stack pointer register is decremented and the contents of the higher order registers B, D, H, A are copied into the location. The stack pointer register is decremented again and the contents of the low order register C, E, L flags are copied to that location. Flags, no flags are modified. Pop of stack to register pair. Opcode pop operand RP bytes 1, M cycles 3, T states 10T. Description: the contents of the memory location pointed out by the stack pointer registers are copied to the lower order registers such as C, E, L and flags. Of the operand. The stack pointer is incremented by 1 and the contents of that memory location are copied to the higher order register B, D, H, A of the operand. The stack pointer registers is again incremented by 1. Flags, no flags are modified. The contents of the source stack locations are not altered after the pop instructions. RSTN restart. Opcode RSTN operand none bytes 1, M cycles, T states 12, T states. Description: this instruction is equivalent to 1 byte call instruction. Here n equals 0 to 7 are 8 software interrupts. Flags, no flags are affected. Copy SPHL, copy HL register to the stack pointer. Opcode SPHL operand none bytes 1, M cycles 1, T state 60. Description: the instructions loads the contents of the HL registers into the stack pointer register. Flags, no flags are affected. This instruction performs the same function as move A, M, except the instructions use the contents of BC or DE as memory pointers. The instructions is used in conjunction to call or conditional call instructions. IN input data to an accumulator from port with 8-bit address. Opcode IN operand 8-bit port addresses bytes to M cycles 3, T states 10T. Description: the contents of the input port is designated in the operand are read and loaded into the accumulator. Flags, no flags are affected. Output data from the accumulator to a port with 8-bit addresses. Opcode output operand 8-bit port addresses bytes to M cycles 3, T states 10T. Description: the contents of the accumulator are copied into the output port specified by the operand. Flags, no flags are affected. EA enable interrupts. Opcode EA operand none bytes 1, M cycles 1, T states 4T. Description: the interrupt enable flip-flop is set. The interrupts are enabled. Flags, no flags are affected. Comments: after a system reset or the acknowledgement of an interrupt, the interrupt enable flip-flop is reset, thus disabling the interrupts. This instruction is necessary to enable the interrupts except TRAP. DA disable interrupts. Opcode DA operand none bytes 1, M cycles 1, T states 40. Or description: the interrupt enable flip-flop is reset and all interrupts except the trap edge 85 are disabled. Flags, no flags are affected. Comments: this instruction is commonly used when the execution of a code sequence cannot be interrupted. RIM read interrupt mask. Opcode RIM operand none bytes 1, M cycles 1, T states 40. Description: this is a multi-purpose instruction used to read the status of the interrupt 7.5, 6.5, 5.5 and to read serial data input bit. Support DA, D7, SID, D6, I7, D5, I6, D4, I5, D3, E8, D2, 7.5, D1, 6.5, D0, 5.5, 7.5, 6.5, 5.5. Interrupts masked if bit equal to 1. EA means interrupts enable flip-flop is set if bit equal to 1. I7, I6, I5 interrupts pending if bit equal to 1. SID means serial input data bit. No flags are affected. SIM set interrupt mask. This is a multi-purpose instruction and used to implement the edge rate for interrupts RST 7.5, RST 6.5, RST 5.5 and serial data output. Remember: D7 SOD, D6 SDE, D5 XXX, D4 R7.5, D3 MSC, D2 MZ, M7.5, D1 M6.5, D0 M5.5. Serial output data. SOD means SDE means serial data enable, i.e. 1 equal to enable, 0 equal to disable. Okay, now R7.5 means reset RST 7.5 flip-flop if D4 equal to 1. MSC mask set enable if D3 equal to 1. D2, D1, D0 mask interrupts if bits equal to 1. SOD serial output data. If bit D7 of the accumulator is latched into the SOD output line and made available to a serial peripheral, if bit D6 equal to 1, SDE serial data enable in this bit equal to 1 enables the serial output to implement serial output. This bit needs to be enabled. Triplex don't care. R7.5 reset RST 7.5. If this bit equal to 1, RST 7.5 flip flop is reset. This is a additional control to reset RST 7.5. MSC mask set enable. If this bit is high, it enables the functions of bits D2, D1, D0. This is a master control over all the interrupts masking bits. If this bit is low, bit D2, D1 and D0 do not have any effect on this mask. M7.5 D2 equal to 0, RST 7.5 is enabled equal to 1, RST 7.5 is masked or disabled. M6.5 D1 equal to 0, RST 6.5 is correct equal to 1, RST 6.5 is masked or disabled. M6.5 D not equal to 0, RST 5.5 is enabled equal to 1, RST 5.5 is masked or disabled. This instruction does not affect a trap interrupt. Remember, data copy instructions do not affect the flags. Operand PSW program status word represents the contents of the accumulator and a flag register. The accumulator is higher order register and the flags are lower order register. Add and subtract are performed in relation to contents of the accumulator. However, the increment or decrement operation can be performed in any register. Out of all instructions, push, call, return, RESTN, INX, DCX, SPHL, and PCHL uses 60 states for fetch main machine cycle. DAD instruction uses bus idle machine cycle. Not operation does not affect any flags. Jump JMP instruction is a type of immediate addressing. Conditional jump instructions allow the microprocessor to make decisions based on certain conditions indicated by the flags. INX and D6 does not affect any of the flags. Compare instructions work like subtraction, but content of the accumulator register does not change. Stack is a set of memory locations used to store binary information byte temporarily during execution of a program. Stack and stack pointers are two different things. Subroutine is also a program written outside the memory program. Call and RET instructions are used for execution of subroutine and after execution return to main program. Interrupts. Hardware interrupts. The 8085 microprocessor has 5 interrupt signals that can be used to interrupt a program execution. For example, interrupt trap, triggering, edge and level, vector address 0024H. Maskable and non-maskable means non-maskable instructions independent of EA, RST 7.5, edge triggering 003CH, vector address maskable controlled by EA, unmasked by SIM, RST 6.5, level triggered 0034H, maskable controlled by EA, unmaskable by SIM, RST 5.5, level triggered 002CH, maskable controlled by EA, unmasked by SIM, INTR, level triggered non-vectored, maskable controlled by EA, INTA whole bar is a hack to low interrupt acknowledgement signal which is only used with INTR to calculate vector address of RSTN n into 8 equal to x of base 10 equal to y of base 16. Example for RST 4.5 into 8 base 10 equal 36 base 10 in hexadecimal 24H that equals 0024H. Software interrupts. There are 8 software interrupts which are used either instructions or along with INTR interrupt. They are defined as RSTN where n equal to 0 to 7. Software interrupts RSTN vector addresses RST0 000H, RST1 00008H, RST2 0010H, RST3 0018H, RST4 0020H, RST5 0028H, RST6 003H, RST7 0038H. Trap is also called RST 4.5 interrupt. Interrupts priority order is trap greater than RST 7.5 greater than RST 6.5 greater than RST 5.5 greater than INTR. Hold has highest priority than trap. Rim and sim instructions are not only used for interrupt processes but also used for serial input-output processes. 8259A is a programmable interrupt controller and used to implement and extend the capability of the 8085 interrupt. It manages 8 interrupt requests, interfacing with microprocessor, interfacing, designing logic circuits and writing program to make the processor communicate either with memory or input-output is known as interfacing. The logic circuits used are known as interfacing circuits or input-output ports. Characteristics memory capacity depends upon the amount of data that can be stored. memory size equal to 2 power a means address lines into d means data lines, 2 power a into d, number of chips required equal to n equal to size of m2 by size of m1, where n small n equal to number of chips required, capital M1 equal to available capacity, capital M2 equal to memory to be designed, initial addresses and memory size is given, then formula for last address equal to initial address in hexadecimal plus hexadecimal equivalent of memory size minus 1 base h. If a memory range is given, then the formula for calculating memory size equal to last address h minus initial address h plus 1 base h in terms of bytes. Interfacing with I/O ports, there are two ways by which I/O ports can be connected to the microprocessor: memory mapped I/O scheme, mapped I/O scheme. Comparison between memory mapped I/O and I/O mapped I/O schemes. Characteristics: device address, memory mapped input output 16-bit, input output mapped in I/O bar, mapped I/O 8-bit. Whereas characteristics: control signals for input or output, memory mapped I/O is MEM whole bar bar, MEMW whole bar, IO mapped IO R bar, IOW bar. Instructions available characteristic అయితే memory related instructions such as LDA, STA, LDAX, STAX, MOVM, R, ADD, M, SUBM, ANAM, etc. comes under memory mapped IO. In and out comes under IO mapped IO. Data transfers between registers and IO, memory mapped IO only between IO and the accumulator. Maximum number of input-output devices possible. Memory mapped IO ఏమంటే the memory map 64K is shared between IO devices and shared system memory. IO base IO means the IO map is independent of the memory mapped. 256 input devices and 256 output devices can be connected. Execution speed 13 T states STA, LDA, 7 T states move M, R for memory mapped IO, whereas 10 T states for IO mapped IO. Execution speed 13 T states STA, LDA, 70 states move MRM. Understood kada? Hardware requirements for memory mapped IO: more hardware is needed to decode 16-bit address. For IO mapped IO, less hardware is needed to decode 8-bit address. Other features: memory mapped IO performs arithmetic or logical operations can be directly performed with IO data. IO mapped IO not available. Interfacing devices Intel 8155 programmable peripheral interface. The 8155 includes 256 bytes of all-day read or write memory, that is RAM, 3 input ports and 16-bit timer. Format of 8155 timer: LSB timer, T7, T65, T432, T2, T1, T0, MSB timer, M2, M1, T13, T12, T11, T10, T9, T8, where M2, M1 modes, M2, M1 00 అయితే mode 0, M2, M1 01 అయితే mode 1, M2, M1 10 అయితే mode 2, M2, M1 11 అయితే mode 3. 00 means single square wave cycle, 01 means square wave, 10 means single pulse after terminal count, 11 means pulse every terminal count. Intel 8255 programmable peripheral interface or adapter. 8285 is widely used programmable parallel input output device. It can be programmed to transfer data under various conditions from IO to interrupt IO. Operating modes of 8255: mode 0 equal to simple input or output, mode 1 equal to strobed input or output, mode 2 equal to bidirectional strobed. Control word for BSR mode: 0x bit select S by R. S bar R means 1 equal to set, 0 equal to set, 000 bit 0, 000 bit 1 not used. 0 for B means BSR mode. Structure of control word: D0, group B, port C lower, 1 equal to input, 0 equal to output. D1, port B, 1 equal to input, 0 equal to output. D2, mode selection of port B, 0 equal to mode 1 equal to mode 1. D3, group A, port C upper 1, D3, D4, D5, D6, D7 means, remember, D3, port C upper 1 equal to input, 0 equal to output. D4, port A 1 equal to input, 0 equal to output. D5 and D6, mode of selection of port A, 0 equal to mode 0, 0 1 equal to mode 1, 1x equal to mode 2. D7, 1 equal to IO bar, mode 0 equal to BSR mode. Intel 8251 Programmable Communicate Interface. Intel 8251 is also known as Universal Synchronous or Asynchronous Receiver Transmitter USART, used to transmit serial data. Intel 8253 Programmable Interval Timer. The Programmable Counter Interval Timer is used in real-time applications of timing and counting, such as BCD or binary counting, generation of time delay, etc. In 8253 uses NMOS technology and operates in any of the following 6 modes. Mode 0 interrupt terminal count. Mode 1 programmable one shot. Mode 2 rate generator. Mode 3 square wave generator. Mode 4 software trigger strobe. Mode 5 hardware trigger strobe. Intel 8257 programmable DMA controller. In a DMA data transfer scheme, data are directly transferred from an input-output device to RAM or from RAM to an input-output device, thus it is capable of performing 3 operations, that is read, write and verify. Intel 8259 programmable interrupt controller. The programmable interrupt controller is used when several input-output devices transfer data using interrupt, and they are also to be connected to the same interrupt level of the microprocessor. Intel 8272 floppy disk controller. The function of floppy disk controller is to interface a floppy disk systems to a microprocessor. 8275 programmable CRT controller. The Intel 8275 is a single chip device. It is a function used to interface CRT faster scan display with the microcontroller. Intel 8279 programmable keyboard or display interface. The Intel 8279 is a programmable keyboard interface. It has 2 sections, namely keyboard section and display section. The function of keyboard section is to interface the keyboard, and the function of the display section is to drive alphanumeric displays or indicator lights. Counter and time delays. Counters are used primarily to keep track of events. Time delays are important setting of reasonably accurate timing between 2 events. Time delay can be introduced using a loop and total delay equal time to execute instructions outside loop plus time to execute loop instructions. TD equal T0 plus TLA. TD equal total delay. T0 equal time to execute instructions outside loop. TLA equal time to execute loop instructions. Normal T0 is very small and negligibly small. Most of the cases, the accuracy of the time delay depends on the accuracy of the system clock. Intel 8254 is the programmable timer chip that can be interfaced with the microprocessor and program to provide considerably accuracy.